Today, we're going to introduce satellites. So, for your do now, I want you to respond to this question. I used a satellite today. Did you? If you can say yes, I want you to tell me how you used a satellite. If you say no, I want you to tell me why you didn't use a satellite. I'm going to give you 2 minutes to write at least 3 lines for me on your sheet of paper. Go ahead, begin now. All right, you have about 30 seconds to finish up, and then I'm going to collect them. Ten seconds. All right. Now, I'm going to go through some of these. What I want you to do is give me a thumbs up if you agree or a thumbs down if you disagree. One of your classmates wrote, I used the satellite today when I listened to the radio because my parents have that cool Sirius radio in their car on my way to school today. What do you think? Is that a good use of satellites? Are satellites used to use that Sirius radio? Thumbs up if you agree. Thumbs down if you disagree. Nate, great job. Thank you so much. Another student wrote, I definitely didn't use a satellite today at all. I was texting the whole way to school. What do you think? Agree or disagree on not needing a satellite to text? A couple of you aren't sure. Well, one of the ways that we use satellites, and we're going to talk about this a little bit more here, is a communication. There's no way that our cell phones, that we can send messages to each other with cell phones if we're not using some sort of satellite communication. And we'll go through one more here today. This person wrote, I used the satellite in my car today. My parents have GPS navigation. Agree or disagree? Satellites, do we use satellites for GPS navigation? Yeah, absolutely. The only way that we can use GPS navigation is if we are using some sort of satellite. So, how do we use satellites? According to this pie chart here, we can see that 59% of satellites are used for some sort of communication purposes. We use 9% are used for Earth observation and remote sensing. Navigation, 8%, military surveillance, and you can see there are some other things as well. Earth science, meteorology, astrophysics, etc. So you can see that satellites play a big role in a variety of areas. Well, how do satellites work? We're going to look at a video here on how a satellite works. And hopefully this will answer a couple of those types of questions. And we're going to use that information then to do a small group activity after the video.
All these communications are possible with geostationary satellite. Orbiting 36,000 kilometers above the ground, geostationary satellites rotate at the same speed as our planet, following its movement while always remaining above the same point on the equator. To an observer on the ground, this makes them seem perfectly motionless in the sky. In actual fact, they move at over 3 kilometers per second without using any fuel, maintaining their initial speed in the vacuum of space. In geostationary orbit, Eutelsat operates a fleet of satellites which cover 2/3 of the planet. Thanks to their position high in the sky, satellites are the essential complement to land-based networks. This enables them to avoid obstacles in the landscape and to connect an infinite number of sites across the Earth. Satellites could be called the network of all networks. They are the favoured means of broadcasting television programmes to households equipped with satellite dishes, or through networks which themselves rely on satellite feeds. In addition to television, satellites also enable high-speed internet connection even in the most remote areas. A rocket can launch a satellite into space and reach its transfer orbit of 1,500 kilometers above the ground within 30 to 40 minutes. The satellite then deploys a section of its solar panels in order to provide a steady power supply during its travel in space. Engine propulsion is used to gradually make its orbit more circular until it describes a perfect circle and attains its final position in geostationary orbit. Once in position, the satellite fully deploys its solar panels and antennas, producing a wingspan of 40 meters. 3 to 4 weeks have passed since the satellite left Earth. Space vacuum, radiation, extreme thermal conditions of minus 150 to 150 degrees. Satellites are high-technology equipment designed to function for over 15 years in a hostile environment. All telecommunication satellites are built for the same purpose, to receive a ground signal and transmit it inside their coverage area. The signal is sent from a transmitting station, which can transport television programs or data, or establish an internet connection. In order to repeat the received signal across the entire coverage area, the satellite must re-amplify it and change its frequency. This is carried out by transponders, amplification tubes located between the satellite's reception and transmission antennas. All the equipment is fastened to a central pod. Radiator surfaces evacuate any heat produced, and heat shields insulate the satellite from the outside environment. In addition to the control systems, the pod houses the propulsion system and fuel tanks. This system maintains the satellite at its station and reduces disturbances related to the attraction of the Sun and the Moon and Earth's gravitational field. The 2 solar panels supply all the energy required for the satellite to fully function throughout its lifetime. This makes the satellite the most environmentally friendly means of communication. Each equinox, when the satellite moves to the Earth's shadow, rechargeable batteries take over. Approximately half an hour after the rocket takes off, the control center establishes the first communications with the satellite. All the equipment is permanently monitored from this point on, and every 2 weeks the propulsion system is actuated to keep the satellite in its station. A second control center monitors signal quality and ensures that each transmission station is using the correct frequencies and power levels in order to avoid any risk of interference. Television represents 3/4 of the traffic of satellites operated by Eutelsat. Present at every step in the video process, satellites transmit images to studios, exchange programs between broadcasters, transmit to satellite dishes and to cable and digital terrestrial headends. Thanks to satellites, landscapes and borders are no longer obstacles. Information can be broadcast everywhere in real time, even to the most isolated areas of the planet, offering all cultures a world audience. In the event of a disaster, the satellite takes over for damaged or destroyed ground networks to restore communications and coordinate emergency operations. On planes, at sea, on trains, and everywhere else that ground networks are absent or underdeployed, satellites provide access to all communication networks. Today, with the arrival of high-definition television and broadband development, man has never been more in need of space to communicate.
All right. So, what we are going to do, let me get the lights. What we're going to do is we're going to look at some very famous satellites. I have up here on the board, I have this in a handout for you as well. I have 10 of the most important satellites that are out in space at this time. We have Landsat 7, the International Space Station. Some of you might have not even thought that the International Space Station is a satellite, but it actually is a satellite. We think of satellites as not being able to have people in it or having to be unmanned, so to speak, out there, or robotic. But not all satellites will be that. Some of them, like the International Space Station, are big enough to put people in them as well. And some other things here. What we're going to do is we're going to break into small groups, 3 to 4 in a group at the most, and I'm going to have you do some research on these different ones. So each group will get to pick one of these 10 satellites, and you're going to do some research on those for us. You're going to tell us different things about them. What kind of orbit do they have? Where are they located? What do they orbit around? What's their job? What's the purpose of that satellite? Why are they out in space? That sort of thing. And any kind of interesting facts that you can tell us about them. Then, after we share all that information, we're going to do some calculation about speed of travel and things like that with those after that. So I'm going to give you the rest of class today to research your satellites. And tomorrow, when we get back together, we'll present that information, all the information that you found out about those satellites, and then we'll go into our calculations and talk about speed and velocity and things like that. Are there any questions before we break apart into our groups? Great. Thanks.